Jai Gurudev student. Today we will discuss about the ionization enthalpy of second period of predictor. So this is the ionization lithium, beryllium, boron, carbon, nitrogen, oxygen, chlorine, neon. Obviously, these two questions may be in your mind that why the ionization enthalpy boron is less than beryllium and oxygen is less than nitrogen. So if I go through their electronic configuration, beryllium electronic configuration is 1s2 2s2. Boron electronic configuration is 1s2 2s2 2p1. So this is more symmetrical, both the orbitals are filled, and it is less symmetrical. So ionization enthalpy is directly proportional to the symmetrical configuration. Take out the electron from an s orbital which is attracted by the nucleus more than that of the p orbital, it will be difficult. That is why beryllium having more ionization enthalpy than the boron. If we compare the case of nitrogen, it is 1s2 2s2 2p3. If I write their box diagram, this is 2s2, this is your 2p3. So this one is the half filled stability, and if I write the oxygen electronic configuration, this is 1s2 2s2 2p4. This is 2s2, this is 2p4. 1 2 3 4. So this one is more stable because it is half filled electronic configuration and more stable. It is why to take out the electron from the nitrogen will be difficult than that of the oxygen. So that is why the ionization enthalpy will be of nitrogen is more than that of the oxygen. Now, apart from this, student, we are going to discuss the radius. Different types of radius are there. First of all, if there is two hydrogen molecule, so we have covalent radius. If it is 198 picometer, 198 by 2 into 99 picometer. It is the distance between the nucleus. Remember, it is the distance between half of the distance between the nucleus of two atom, two homonuclear atom. So next one is your, now if I have HCl instead of HCl, then one radius must be known, internuclear distance must be known, and one radius must be known. That is, from this you can calculate hydrogen radius, subtract one from the other. Then we have ionic radius. So it is defined as the distance between the nucleus of the outermost shell of an ion. So if it is NaCl, so if it is Na and this is Cl, the radius of this one, this is radius of cation and this part is radius of anion. From nucleus to here, it is radius of anion, this is cation. Now, in ionic radius, one point you remember, student, that the size of cation is always less than the neutral atom. For example, if it consider an egg, the boiled egg, So when you want to have that egg, you have to remove the outermost shell. The cation we are obtaining by removing the outermost shell. Obviously, the portion of egg that you have ate, that one is smaller than the whole egg. Another point to remember, the size of anion is greater than that of the neutral atom. Then why the size of anion is greater than that of the neutral atom? Now in anion, if another electron comes in the outermost shell, then there is a repulsion between the electron. That is why size expands. Similarly, we can tell that if we consider our solar system, if in solar system one more extra planet comes, then the force of attraction of the sun will be less in each of the planet. Earlier it is 100 divided by 8 for one. Now it is 100 divided by 9. Obviously less. Now if the one planet is removed, then what will happen? The size of that now 100 divided by 8 divided by 100 divided by 7. The attraction force increases, size decreases. So that part also is required to remember. Next, we are required to remember another radius to radius. Actually, two more type radius we will read in next unit. Next is your electron gain anthem. It is the energy change when an extra electron is added to neutral gaseous atom to make it anion. Now A is a gaseous atom. In that one we are adding an extra electron. We are getting A negative. So this is whenever you invite an electron in there is two forces operate actually. This is your nucleus, these are the shells. Now this electron, there is two types of force. This is the attraction force from the nucleus to electron, and you have to set the electron in the outermost shell. But this say like charges is repulsion. So if attraction force is greater than or equal to the repulsion force, then electron will come and join in the outermost shell. Now in that case also, if we have two variations are there. In case of oxygen, sulfur, selenium, tellurium, polonium, O style से तेल polish. Then chlorine, bromine, iodine, astatine. It is found that the value of oxygen is 141, it is 200, it is 195, it is 190, and it is 170. Chlorine value is 328, then 349, 325, 295, 270. All are minus. Student 1 point to ignore the minus. Minus is due to attraction energy released. Here to here the general trend is that minus, forget about the minus, there is decreasing, this is also decreasing. But the question is here that why oxygen is less than sulfur and fluorine is less than chlorine? The answer is that the size of the oxygen and fluorine is too small. This is the main reason. Due to this small size of oxygen and fluorine, the incoming electron under high amount of repulsion. For example, if attraction is 10, repulsion is -8. Attraction is 10, repulsion is -8. But for sulfur or for chlorine, the electron is added in the larger electron count. Due to this, the attraction, for example, sulfur attraction we consider 9 and repulsion is -4. Attraction is -9, repulsion is 4, then net force in case of sulfur is 1. You student, one point remember, oxygen due to small size, the incoming electron which is going to set in the second shell under high amount of repulsion. Due to this, the electron gain enthalpy of oxygen is less. Similar case for the fluorine.